Good afternoon. I hope you are doing fine. Today I want us to look at contact of circles, and as you can see on the board, I've drawn two sets of contact circles. And what we mean by contact circles is that these are circles that are touching each other at a point on a common tangent. Now, for example, this is a bigger circle here whose center is B, and then we also have a smaller circle inside it whose center is A. Now, these two circles are coming into contact at point T. One thing we need to note about these two circles is that the radii, that is B and A, and the point of contact are in a straight line. Therefore, if you draw this tangent here, the straight line BT is meeting SR at a right angle. Now, these two circles are said to be internally in touch, or they are internally in contact. The second set here, we have two circles also, whose centers are X and Y respectively. The two circles are also in contact at point K. Now, the line YK is making an angle of 90 degrees with the tangent JK. At this point, this is an angle of 90 degrees. Now, another thing we need to note, if you want to find the distance between the centers of these circles, for the first set, which is the circles that are internally in touch, we say we have BT minus AT. This gives us the distance between the centers, which is actually AB. With the second set of circles, the distance between the centers is just simply the sum of their radii. Therefore, we can say that XK plus KY equals to XY. Now, we want to take an example of a question that involves circles that are in contact. So I'm going to read the question of this example. The figure below shows tops of two circular tines in contact at T. The tines are of equal height but different radii. The centers are X and Y. A is a point on their common tangent such that AY is 15 centimeters, AX is 13 centimeters, and AT is 12 centimeters. Calculate the distance between their centers. So as we said earlier, when the two circles are in contact externally, we add their radii to get the total distance between their centers. So as you can see here, because this is because TA is a tangent, then it means that triangle XTA is a right angle triangle. We can get this radius TY, so we can say that TY squared equals to 15 squared minus 12 squared. This is going to give us 225 minus 144. Then we find the square root. This is going to give us TY, which is going to be 9 centimeters. Of course, we get here plus or minus 9, but we ignore the negative because we don't have negative distance. Then the same thing we do with radius xt. We say xt squared equals to 13 squared, that is XA, minus 12 squared, which is TA. Then xt will be equal to the square root of 169 minus 144, which is equal to the square root of 25, which gives us plus or minus 5. Therefore, we ignore the negative and say we have the distance xt as 5. But now the question was calculate the distance between their centers. So the centers, the centers are actually from x to y. Therefore, xy equals to xt plus ty. So xt is equals to 5, then we add 9, and then we get 14 centimeters. So the two centers are 14 centimeters apart. Thank you. But I want to give you an exercise. You can attempt a question from KLB, Book 3, KLB Book 3, Exercise 7.5. You answer question number 3. You answer question number 3. Have a nice time.